Okay, everything is working. So welcome everyone to Advanced Eagle Episode 2. In this episode, our goal is basically to discuss the options in Eagle to accelerate via stitching. So the first thing I'm going to do is go ahead and share my screen with you guys. Okay, please let me know if you can see my screen. Okay, cool, excellent. So I've prepared for this episode basically a very kind of dumb schematic, and the idea here is not so much the signal. The focus is really on the PCB, but as you can see, basically I put in a PCB design which comes from Dangerous Prototypes. They have something they call the Stick of Beige standard. So they've made a bunch of standard size board layouts, and I wanted to play with them a little bit, so I've included them here just for as a show me. As you can see, the schematic consists of just two resistors connected to ground with a net between them. Okay, obviously in a practical sense, this doesn't really have much use, but the goal, again, is just to show how via stitching works in Eagle. So let's go to board, which is where the magic is going to happen. Okay, so you can see the board outline, okay, which is the Dangerous Prototype standard. I've drawn two polygons, okay, one on the top, one on the bottom. They're both named ground, and we can confirm this with the name command. Okay, ground. And if I select it and right-click, now I get the bottom one, ground as well, okay? So first thing I want to show you, because maybe you guys have run into this before, maybe you haven't. Okay, if I just rat's nest right now, only the top polygon fills in, okay? And the reason for that is that I don't have any members of the ground net on the bottom. There's no via right now that connects to the bottom layer in order for the polygon to hook onto something. So temporarily, this is considered an orphan, okay? So just to keep that in mind, it won't be an orphan for long, so no worries. So easiest way to do stitching, as you can see here, we have what could be a signal trace in a real-world design. And we want to go ahead and put stitching vias along near the side of the trace, okay? Let's say that's what we want to do. So before we get started, let's talk a little bit about what stitching vias are. Okay, if you've observed the Jeremy Bloom tutorials, you'll see that Jeremy Bloom, after he's done all the routing and everything, he would just drop vias at certain places in the ground plane to tie both the top and bottom ground planes together. Okay, the benefit of this is that, number one, you maintain a short impedance to ground by having more vias. Basically, there's shorter separation between the two planes. But the via's real benefit, or one of their benefits, is that they, number one, help make sure that there's a uniform low impedance to ground. Okay, by making sure both planes are solidly connected in various places, that assures a low impedance to ground. So for RF circuits, that's very important, because at the higher frequencies, the higher the frequency of the signals you're dealing with, the more chances are that the parasitic, the imperfections of your polygons, are going to now start to play a role, and they will no longer look like ground to the signal. Okay, and that can start to create issues with your design. So that's one of the reasons. Another benefit is obviously thermal dissipation. In cases where you have a lot of current running through a plane, having lots of vias to divide it up between allows for better current flow. Also, when you have lots of vias under a part that radiates a lot of heat, the vias can help conduct that heat to the other plane. So there are really a lot of benefits to this. The final one, and the most important one for RF, is basically shielding, okay, or what is known as via fencing. Okay, and what this allows you to do is kind of create a Faraday cage type effect and stop emissions coming off the board. Okay, so those are the key points as to why we want to do this. Now in Eagle, there's various ways we can do this and various tools that can aid us to do this. So I'm just going to show you, starting from simplest to the most sophisticated, okay? So the simplest route is to just click on the via command, okay? Set up the parameters of your via, however you want to set them up. Let's say 27 here. Diameter auto is fine. Okay, you set up your via parameters, and in the command line, within single quotes, you put in the signal that the via connects, in this case ground. Okay, single quote, open single quote, GND, close single quote, hit enter. You'll notice that Eagle won't complain. At this point, any via you drop is going to automatically be connected to the ground signal. So for example here, we could do something like this very easily. And again, the big help here is that we entered the name of the net first. That makes it very, very easy to just place them and know that they're all connected to ground. We can confirm this. We use the name command, ground. You see, everything is connected. So now we can go ahead and hit the rasness, and we'll see that the bottom polygon also fills in. Okay, so again, by putting in these fencing vias, we really help avoid emissions from this signal, if there was real signal here. Obviously, let's pretend there is. We help control the emissions coming off of this trace. Okay, so that's the simplest application that we can think of. Okay, now we can take it a step further. I'm going to go ahead and remove all of these but one. So using the rip-up command, go ahead and remove these. I'm going to leave one because I want the polygons to still be able to be calculated. Okay. Now, let's say we want to do it like I mentioned before in the way Jeremy Blum did it, which is to make sure there's a really nice, uniform, low impedance ground. Okay, and basically that was by placing vias anywhere he had an open space. Well, there are tools in Eagle that can help us do this. Okay, one of the more elephant gun approaches, and that's why I said, we started with the most basic, which is manual. Now we're going to get some assisted tools. Okay, we click on the UOP icon, and we can download from the CADSoft website a UOP called VFL. Okay, we hit open. Basically, what this UOP does very simply is it basically asks you the available nets. It looks at what nets are used by the polygons. The polygons in this design are only using ground. So I click add. Okay, and we also determine what's the spacing we want to have between the vias. So let's say we want to have 0.1. Okay, and then all we do is we say place vias. Okay, it'll tell you check these two scripts in the scripts folder. So basically what the UOP does is looking at whatever traces are on the polygon, it calculates basically on a staggered grid via locations. So let's go ahead and run that script that it generated. We click on the SCR. We go to the built-in scripts tree of Eagle, which is over here. And we see here via pose and via pose undo. Okay, here's the idea. We run via pose, we'll get all the vias in. See? All the vias are in. Okay, nice staggered grid. You'll notice that they maintain a good separation from the trace. They don't crash into it. They don't do a perfect job. You see there's some overlap here, and there's also some clearance violations over here. They're obviously going to short to here. But, as you can see, it does a pretty good job of evenly spacing these vias. Okay, so again, for thermal considerations, even in an RF case, usually for, as we know from electromagnetic theory, a quarter wavelength trace or a quarter wavelength piece of copper can behave as an antenna. Okay, so as long as we keep the distance between these vias to about 1/8 of a wavelength or less, then we know we can maintain a pretty solid ground plane. Okay, so something like this you may want to clean up just by ripping up a few of these. Rip up this one. Okay. The via pose undo basically allows us to undo this if we didn't like the end result. Okay? But this is pretty good here. Probably a bit excessive for most use cases because obviously we have a lot of vias here stitching, but it gives you an idea of what's possible. Okay? So the last example I want to show is arguably the most sophisticated one. So let me go ahead and just rip up all of these. Script. I'm going to go ahead and run this one. Okay, cleaned up almost everything. Left a few here. That's okay. Won't always do it perfectly. Okay, we'll rise and this again. So I have this one here. So this last one is very impressive, and this is why this outline is here. Okay. Basically, if we draw a contour on layer 46 milling, that's a 0 width, the Create Drill Line Array, ULP, which is this one here, can use it as a guide and place vias. Okay, so you'll see here Drill Array Creator version 1.21. This is also available on our website, cadsoftUSA.com, under Downloads. Okay, and here we specify the guide layer, which is layer 46. It's going to look for a 0 width. We have units of mils. We can specify what type of hole we want here. Okay, we can say a through hole. We can say vias with 4 solder masks, or vias which the DRC determines the solder mask. We can specify via options round. We can also, for example, apply a trace, an outline, okay, on a specific layer, or we can change it later on. So here we apply an outline. We can put it on a copper layer. So basically we can have vias within traces, which again can be very useful in RF situations. We can apply stop mass to that whole trace. So there's really a lot of power in this tool. Okay, here we have the drill diameter. I'm going to go ahead and set it to 27. We have 2 options. If we leave the signal name alone, then they're all just going to be, free vias. In this particular situation, it's not useful, so we're going to name them ground. Now, we can specify the number of holes, 50, or we can enter a pitch. Okay, if you select this one, even if you have a value here, it will be ignored. So let's go ahead and I'm not going to check the hole pitch. I'm going to leave it at 50. Okay, we're going to say start, and we'll see that it automatically creates the vias. Okay, all spaced appropriately. Again, this again can be used to help limit the emissions off the side of a ULP, off the side of a board. Now again, normally this will be closer to the edge of the polygons and blah, 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 but you get the idea of what we can do here. Okay, well, I got somebody on loud. Okay. Here on Q&A we have some questions. Questions? Let me see if anybody else had their phone on. It's weird. Okay, no, there should be no issue there. Okay. Don't know what that was. Okay. So as you can see, we can very easily space these now to remove them. This one, we don't have the a script to undo them like we did with via fill. However, if we just hit Control-Z and hold it, you'll see it starts to basically disappear. Okay. Now again, we can run it with a different option here of entering the pitch. So we'll say ground again, via DRC determines. I'll put in the pitch of 100 mils, okay, because that's our units. And let's see how many we get in here. They start, and there we go. See? Our result. You'll see it on the curve. Sometimes they'll get a little bit tighter. But overall, it's okay. Again, as long as they're less than 1/8 of a wavelength, then you'll be okay. Okay. And again, you can use any arbitrary contours. You can see here I have lots of curves. Okay, it doesn't have to be a perfect rectangle. It can be any sort of shape. I could have used the same tool to make the ones along the side of the trace like we did initially manually. But these are the options for via stitching. And like I said, its biggest applications are usually in RF for conduction suppression as well as noise suppression. Now, if you don't work in RF, this still may be of value to you. If you work, for example, with low-level analog sensors where you really need to keep things quiet, these type of techniques can help you keep those signals protected and immune to stray noise. Okay? So keep this in your back pocket. This may be something useful in the future for your own designs. And if you guys have any questions, please feel free to submit them now. Okay? Any questions about this at all, feel free to submit them. If there's anything you'd like to see in regards to this, please let me know. Where do you find this tool? Okay, that's a good question. I'm going to click here on web. Well, you go to our website. Okay. This is cadsoftusa.com under downloads, user language programs. Okay. Users submit these all the time, and there's lots of good tools that you can search for. Basically, you put in a search query, and then Eagle will limit the result. The website will limit the results to basically anything that includes the word, in this case, via, either in the name or in its description. Okay? So basically, you can scroll down. You'll find the Create Drill Line Array over here. Okay? And if you scroll down further, you'll find VFL. All you do is download. Go ahead and give each one a like. Here we go. Okay? Likewise, there's lots of other tools here you can find. I mean, whenever you're in doubt or you're looking for a specific function in Eagle, you don't see a way to do it with the normal commands, just come here and do a quick search. You'll usually find what you're looking for. Like, for example, bill of material UOPs, BOM, you know, we're filthy with them. There's so many bill of materials UOPs. You know, one of them is likely to be useful for your application. What else? EXF also has a lot of different results. Okay. Like that, many other things you can try out. Many different tools that are available. Some of them are old. Okay. Some of them are older, but still useful if you have an older version of Eagle. So definitely, you know, every once in a while it's good to come here and just do a little search, take a quick little look, see if there's anything of import. Okay. Mike Schoenberg. My needs would be more on thermal issues, power devices. Does the process change significantly? It does not. In the case of thermal issues, you would use something like the VFL UOP that I illustrated earlier, the one that was basically an elephant gun to put all over the polygon. So basically, you could do that within even, that wouldn't work within the library, I believe, because polygons in the library don't have names. But on a board, you could do the same thing. Wherever the VS connect to, wherever the LEDs connect to, if you have a polygon there, you can just run the VFL UOP, make sure you select what net that polygon is on, and it'll produce them for you automatically. You know, I could probably split this big polygon a few different ways, and we would get the same results. So let me go ahead and do that, just for the sake of argument. Okay, let's do a rip up at symbol. Okay, we're going to go ahead and minimize this. So what I'll do now is, okay, I'll bring this corner down a bit. Okay, it's about to get a little funky. Okay, and what I'll do is I'll put in a couple more of those polygons here. Let's put it on the top. sure it at least grabs one of the little... Okay. Let me move this one so it also grabs some of the Vias, because otherwise... Oh no, I deleted it. Okay. So again, I'll name these ground. Now they don't necessarily have to be named the same thing, so let me actually give one of these a different name, A ground. Okay, and if I do this, we'll see that it avoids these like it should. It grabs the others. Okay, so if I go ahead and run that via fill UOP here, you'll notice we now have two types of nets. So you can specify which one you want. So let's say A ground, we're going to add it. We're going to also ground normal. And we'll put the same spacing, 0.1. Say place vias. It'll take a little bit. It'll say it's done. We go script, via position, hit open. And it only produces them here on the first one. So I stand corrected in that. If they're separated, then you'll have to do them on one at a time. Let me try with just undoing this one and see if it'll do one of the ones that's filled now, because it'll also just touch the ones that are filled in, I think. Okay, ground, add, this via, say OK. Script, didn't add that one. Maybe didn't have enough room. So here you're discovering some of the limitations on UOPs. Some of these are a little bit old, so they do need some updates, but they are also all user submitted, so you can go in there and play with them a little bit and maybe get closer to the result you want. So via fill, let's make this 0.05. I'm just going to add ground. Place vias. Sometimes it has issues overwriting. Yeah, it's just not going for it. Okay, but that would be the basic idea. And then probably with a little bit of review, I could look into it. If it's something that you need and you see yourself doing this a lot, then let me know and I'll look into that VFL UOP and we can maybe expand its use a little bit better. Okay, but the process should be about what we saw at the beginning. Okay? Sorry about that, Mike. I hadn't tried it. I thought it would do it. Okay, any other questions, guys? Yes, there is more questions. Over here. Okay. Once ground is selected on the command line for individual VS, how is that unselected later on? Okay. So what you'll do later on, for example, let's say VS, right? And right now I don't remember if I left it with the name ground, so let me put 1 and check. Okay, no. Doesn't have the name now. So basically the name sticks during one instance. But let's say we had put in 20 grounds and now we need to put a couple of A grounds. Then all you would, let's say we have a couple, we put in 20 grounds right now. Okay, we put these. Okay. Now we can put open quote A ground, hit enter, and now these will be correctly named. Okay, so for rat's nest, you'll see that everything is okay. So you can just type in another name. With the via command active, you can go ahead and type in another name. Okay. So Ryan, is it because there is no bottom ground plane under your other polygons? That's a good question, Ryan. Let me go ahead and try doing that, see if that makes a difference. You might be right on that. Thank you for the observation. So let me go ahead and put this one here. Okay. Doing info here. Oh, have to use the name command, of course. Falling asleep at the wheel. Okay. Round. There we go. Good spot, Ryan. I think that's what it is. So thank you for that. Okay, name for these is going to be ground. Ground. Whoops. Okay. Make sure everything is filled in. Now let's try that again. Ooh, I got something else here. Oh, no. Alright. If you right-click on the UOP, it shows you the list of all the recent UOPs, so I'm using that to speed this up. And we add this one, give it a shot, see if this works. Yeah, it worked. That was it. That was it. There we go. Thank you, Ryan, for the observation, for helping me out with my brain fart. That was it. Obviously, it doesn't take into account any vias that are pre-placed, as you guys can see. So if you pre-place any vias, it's going to take over. Okay, but if you have everything clean, then it will take care of it. Okay? I can actually just rip everything up and, yep, okay, there we go. I wonder why I didn't rip these up. Didn't leave anything selected. Let me try that again. Curious. Okay. Drawing a little trace over here. Okay. So go ahead and rat's nest. Interesting. This one connected for some reason. Let me go ahead and use that tool again. Via fill, we'll add 0.1. Nice vias. Script. Here completely. But these the bottom couldn't fill in before. So that's another requirement. The bottom polygon also needs to be filled in. Okay, so let me go ahead and just put a V on each of these so that it'll fill in. Round, M, add, yes. Oh, because I didn't rat's nest them before. Duh. There we go. Okay. Now I think we're good. Hey, any other questions, guys? Go ahead and stop sharing the screen. Okay, I think I answered the question from Bob. But basically, if you want to get back to the original state, Bob, you just hit escape to stop the command, and then you can click via again, and it'll work. Okay? You'll basically be able to rename it, or you can rename it at any point in time. Okay, any other questions, guys? Anything else? Okay, if we don't have any other questions, thank you very much for coming to episode 2 of Advanced Eagle. Please feel free to send any questions, concerns, comments to support@cadsofusa.com. My name is George Garcia. Thank you very much, guys, for joining me on this episode 2 of Advanced Eagle. If you guys have any suggestions for future episodes, okay, they're more than welcome. I'm probably going to run out of ideas soon, so anything you guys can send my way for Advanced Eagle, or even for first flights, if there's something you're interested in seeing, let me know. Okay? Thanks, guys. Have a great day. Take care, everyone. Bye.